We are talking about triangle congruence, and we want to prove triangles are congruent based on given information, and we want to follow these steps in order to do that. So we don't have to redraw these triangles because they're not overlapping, so we can go right into our given information. And we notice that there's some spots that are filled in already. So first piece of given information is line segment AB is parallel to line segment CD. So AB is right there. So the parallel symbol is to put matching arrows or matching triangles on those and going in the same direction. So AB is parallel to CD. Now the other thing to notice here is we're trying to prove that triangle ABC is congruent to CDA. So I can write this down here in the last line. Triangle ABC is congruent to triangle CDA. So based off trying to prove these triangles congruent, what would the idea of parallel lines help me with? And remember, parallel lines give us congruent angles. So we have two parallel lines cut by a transversal, and so we have alternate interior angles are congruent. So mark that one with 3, mark that one with 3, and so we have angle and angle, and we want to name these angles correctly. So in order to name these angles correctly, we can match based off of the triangle name. So we want A in the middle. So if I said BAC, so angle BAC, BAC. So which one matches up with B? B is in the second slot. So that's going to match up with D. So it's going to be angle D. A is the next one. A was first, so C is next. And C was last, so A is last. So now we have the angle named correctly. And the reason that we can say that those are congruent is because of alternate interior angles. So the parallel lines ended up giving us those congruent angles based off that relationship. Next, we can look at line segment AB is congruent to line segment CD. So line segment AB, 1, 2, 3, is congruent to line segment CD, 1, 2, 3, and that's a side. And the reason is given. So this piece of information was given there, and this piece of information was given here. We had to come up with the alternate interior angles, and then we're also given this last space, which we're trying to prove. So we got to come up with one more, either another angle or another side. And in this case, we have another side, which I'm going to mark this with 4. 1, 2, 3, 4. So in triangle ABC, I'm just going to call this AC. So I'm going to call this line segment AC is congruent. And again, I'm going to use this, the way they name this triangle over here, to make sure I name it correctly. So A is first, so that should match up with C. C is last, so that matches up with A. And so now I have line segment AC is congruent to line segment CA. So then I know that the reason that I can say that those two sides are congruent in this case are by symmetric, the symmetric property of congruence. And the reason it's not reflexive is because, again, the way that I named the first one was AC, and AC corresponds to CA, so it's not written the same way. So that's why it's the symmetric property. Now we can look. We have a green S, we have a red angle, and then we have a blue S. So those triangles are congruent by side, angle, side. And then we can finish it up by saying QED.